Okay, everyone should be seeing my screen right now. Here we go. So this is a presentation on Clojure and Clojure on AWS Lambda. It's a serverless computing thing, and it's about Ellipse-like language on it. I'm Michael Langford. I am Michael Langford, MJ Langford on Twitter. That's my email address, and I work at a company where I make iOS apps for people, and I use Clojure for the backends for them. So what are we talking about tonight? Tonight we're talking about Lambda, why a business would choose to use it, and why a technical user would choose to use it. What is it? It runs on Linux, and it's on servers that are entirely managed by Amazon. You can't intentionally turn on a Lambda server. They turn them on as needed or off. You can run JVM, Node, or Python in a supported fashion. You can shell out from Node to many other languages if you want, but that's sort of iffy. They call the unit of use a function. I would really say they're microservices, especially for us on JVM languages due to the way the JVM starts up and such. You also have to package JSON out for a lot of the services, or a lot of the functions. So to me, it really feels more like a microservice than something that's really a function. But, and this is the really cool thing, they can only run sometimes for 1 or 2 milliseconds. And you only get charged for those 1 or 2 milliseconds, which is really interesting when you're talking about large-scale systems or systems that are only used infrequently or all sorts of things like that. Lambda is also really easy to connect to things. There's all sorts of things that you connect it to. Amazon makes these buttons they sell you for $5 that you can connect it to. The open microphone in your home, known as Amazon Echo or Amazon Alexa, you can talk and you can send commands, and your Lambda functions can parse them. You can build relatively normal-looking web applications if you use a something like ClojureScript and do some JSON requests. There's all sorts of different ways you can connect Lambda up, and there's a lot of graphical user interface support on the Amazon side to connect up Lambda functions to all different sorts of things. They're very flexible for getting things done. Now, why does a business care about Lambda? When you are doing a business with a normal server, sometime you need more compute capacity than you have right now. This gives you the amount of compute capacity you need this second, and then it goes away. And that is very good for things that have big math problems, things like that. Additionally, normal servers, they sometimes hit exceptions, or they run out of disk space or things like that, and they die, and they don't automatically come back necessarily. Additionally, sometimes your application may have 5,000 active users, sometimes it might have 5 million active users, and you can choose to leave your capacity up high and pay for it, or you can try to move your capacity around, but then you run into peaks and nulls that are sort of a bit of a problem there. And it's not an easy problem. Additionally, if you choose to go on the high side of capacity, you basically have a computer sitting around doing nothing that you're paying someone for, like Amazon or another hosting company. From a more quality of life for a programmer standpoint, you have some pain points because you have to put people on call when you have servers. You have to have them waking up. And I'm not saying you're going to get rid of PagerDuty with Lambda, but that is a big problem, that you lose sleep, even if it goes off at like 8 or 9 p.m. sometimes, because you're up for hours trying to fix it. Then you have to wind down. When your servers go down, clients get angry with you. That's bad. If you have customers instead of clients, that's also bad. Either one can cause your pocketbook to have less money in it at the end of the month. And when all of a sudden your service becomes more popular or goes under load, and sometimes doesn't become more popular, just people start using it in a bad way or an unforeseen way, you have to go to work and work more hours sometimes to get it working in time. Does Lambda solve all this? Sorta. Not enough computers. Yeah, you can get a lot of computers at your problems. If you're really going to get an obscene amount of computers, you want to call Amazon up like literally on the phone, and say, "Hey, help me with this," and they'll set up everything to make it so your obscene amount of computers will show up. Servers, yeah, they fail, but there's a new one to take their place. It's like the sci-fi thing about all the robots standing in line, or the Roman legions that are just endless. It doesn't matter if your server fails. Amazon will pop up another one, and you're fine. You can run out of resources, but generally speaking, it's not anywhere near the same way as a traditional server. Additionally, with Amazon Lambda, you don't have to take anything to add capacity. It just adds it for you. And it only runs a couple milliseconds or maybe a second for a really long task, so you don't get really billed much at all. You still need a PagerDuty thing, but no one ever really gets paged. And when they do, it's more like the Amazon outages where everyone treats it like bad weather because the entire internet really doesn't work. They're not like, oh, you were a bad person, you did it wrong. And you're eating the crunch time at the beginning in a way, but when you can plan for stuff like that, that's better because you don't have to re-architect for scale because you've already picked a scalable architecture. Sure, you might not get it exactly right, but the fact that you're already packaged up for it, that's pretty good when it comes time to get things going fast. So money, is this a good savings technique? No, it's an okay savings technique. You're basically upfront choosing to build for the eventuality where you might scale. That is expensive, and that violates the Yagni principle. That's you're not going to need it idea. And I think in modern systems, that is not necessarily true, but we're going for that right here. It can be a little complicated for people who are used to a normal server architecture to get used to these little bitty things that are idempotent and don't store any state locally. I think functional programmers won't have a big problem there, but there is some organizational retraining sometimes. And so it might be a net loss for organizations filled with a bunch of software developers and system administrators who are very used to the old model. But for people who do not have those people, auto-scaling platform as a service platforms such as Lambda are great. In particular, mobile is great because mobile is often, here's a big pile of people, and if you fail to service those people, you will never get them back, or you will get them like a section of them back, and you will have to beg, cheat, and steal to keep them. So the fact that you can scale and you don't have to worry about all of a sudden getting 10 times the amount of attention because someone wrote an article about you in the New York Times or TechCrunch, it's a bit of peace of mind. I would still be watching those dashboards when that happens, but you've already solved that problem in case you get more attention than you were looking for. But you don't have to do Amazon Lambda to do those. I'm not going to pretend this is the only thing in the world that does that. That would be disingenuous. Google App Engine is an old standard that does that. Heroku, people were using that like crazy, but they sort of got rid of the free tiers, and it also does some of that. It runs into some scaling problems on the upper end, though, that App Engine and Lambda do not. Amazon also has other products, like Elastic Beanstalk, which take a more traditional server and try to scale them. And then Apple makes CloudKit, Google makes Firebase, and Facebook makes Parse. And all of those basically copy a database between a bunch of different computers for you. And a lot of people who do client-side programming but don't understand server-side programming really love those. But the fact that this auto-scales is very useful when you're trying to do something on Heroku and you're running out of databases and something like that. Database connections, not databases. Additionally, these backend as service things haven't been monetized very well by anyone. And the biggest one, Parse, just got end of life, or actually they announced the end of life. It doesn't get end of life until next spring. And so you're really at a risk of that. And when you are running client software such as the mobile sphere, you don't have the ability to make people update their phones. So you can have some really nasty problems because you have to stick a bunch of software on their phones or on front-end web services or in desktop software that you may not be able to get them to update. And this complex software is not necessarily what you want to have sitting around everywhere because it may not do what your business needs it to do anymore. When you can put stuff on a server, you can go change that, and just as long as you're talking the same interface and you test it out, you change your stuff. So that's the big advantage over the other popular thing people are doing, the boss. So how do we do this? This is the technical case. You can connect Lambda to almost anything. Sometimes you have to go through an Amazon service. Sometimes you just need to go through a library in the client language of your choice. This first architecture on the top right here is just using an Amazon library. You talk directly from the software on a computer or a smartphone, and you talk directly to a Lambda function, and the Lambda function talks directly to DynamoDB. There's no API gateway, no anything. The next one, you stick the API gateway in there. The API gateway is a marshalling and a switchboard tool made by Amazon that you can make some endpoints for a REST type architecture. Go to Lambda functions, different Lambda functions, EC2 clusters, all sorts of different things you can point things to with the API gateway. And it's designed for primarily JSON style APIs. Like I said, you can connect up to these Internet of Things buttons. They cost like $20 right now. Amazon has a queuing service, which is basically designed for unidirectional information, typically going to things like Lambda. So you might have a button that queued up an event in the simple queue service. Lambda processes it, stores something in a database, and then some person, when they come into work on Monday, they check out on their analytics client. Additionally, you don't have to use these NoSQL databases, the DynamoDB type thing. You can just use a normal relational database, either on a server you control or on a server running on one of Amazon's relational database systems. And here's more, like there's the top one right there is processing images for people. You guys get the idea. There's a lot of different ways you can go with these architectures, and Lambda can talk to all of them. Here's what we're doing tonight. We're having a user. They have a small piece of software, and I do mean small. We're going to configure the API gateway. Then we're going to have a Lambda function, and then we're going to store our information in the NoSQL DynamoDB. Okay, our user story, there's a guy named Melvin. He signs up for an event. He wants to see who is at the event, and who else is, and he wants to see that he is definitely at the event. Then he is just going to go to the event in person and do it. If you were going to start doing this in person, what you would have to go do right now is you would have to log into your Amazon account, give them a credit card, and you can log into the same Amazon account you buy like diapers and whatever from. I mean, it's that Amazon account. You go to aws.amazon.com, and then you set up identities. Basically, for this presentation, I'm going to assume you set up this identity that has way too many privileges for real life. When you are done and you actually have a running product on this, you should take most of those privileges away from your user, and you should give them to the account that does your continuous integration. This URL right here shows you how you do IAM setup, and it's actually one of the pretty good tutorials on Amazon's side. Some of them are of lower quality than others, but this one's good. Okay, so we have our person, Melvin. What are we doing for a software client? This is a JSON interface, so I can't just toss a web page up there. I'd have to do some XML HTTP requests. So I'm just going to do a command line client. I'm going to use a tool called curl, C-U-R-L, and it allows us to pump JSON at what we want it to. Now, we're going to talk about the next part because it's really like a one-line script. The API gateway. This is the part that hurts, but you're almost always going to want to include it when you're messing around with Lambda, unless you're doing a very personal task. It's one of the ways you get security in your system and you check authorization. However, it has a relatively complex GUI that's hard to get going right, and they give you instructions, but there's no easy way to tell this part of the UI is what I need to go to now, and that part of the UI is what I need to go to now. And they don't have an overarching tutorial that goes step by step in a way that you definitely can follow. So, hopefully, with the example program I've created for all of you, you will be able to skip many of the hard parts of that tutorial. You can also use a Swagger specification file, which is, if you don't know, a way to do APIs by writing out a YAML file, and you basically say, here are my endpoints, here are the methods on my endpoints. This Swagger file has a bunch of stuff in it that is AWS specific, though, so you will have to probably export one to get it working. To use the gateway, you give a specification using the GUI or the Swagger. Then you push the deploy button, which is on the web, or you can use line again to do it. And then you can, from that point on, hook up the different methods to something like Lambda, and you can specify how we're marshalling the things in and how we're marshalling the things out. But in practice, I said, the GUI, it's a little rough. Additionally, you're probably used to easily debugging like post requests that are like form encoded or that are just in the URL. It's a little bit harder to debug JSON style requests. Additionally, when the thing fails, you can get some stuff in an Amazon service called CloudWatch, but it's not necessarily obvious that you should be looking at that. And two, it's not very easy to understand why something failed. Like when something times out because the instance didn't start up, it doesn't say something other than it timed out, and you don't have any reason why it timed out. And one of the libraries we're going to use gives you this pile of JavaScript to paste in part of the configuration, and it doesn't really explain what's going on with that, but you can paste it, it will work, or you can use my YAML file, and it already has it in it. But that really sort of grated my teeth that that's not really explaining what's going on or why we need that. Why do you care, and why would you use this thing I'm telling you is horrible? Well, it gives you SSL. You know, you're secure all of a sudden, and you can use that URL. You don't need to buy a domain name necessarily. You can pick your authorizer. You can write one, or you can use Amazon service, which is called Cognito. You can use Amazon's caching service, which is called CloudFront, and so basically you can run your Amazon Lambda once, generate the cached thing, and it ends up pushed out to the edges of the network. It's pretty nice. If you find part of your service can't be written on Lambda due to the constraints of the system, you can go make a EC2 server to be a little part of it and have that one thing solved that way, and everything else can go to Lambda. It's really flexible that way. Additionally, it looked really cool when I saw this, but it's not that useful in practice. If you've set up all the entities and such, you can go to this one page of the API gateway and just say, give me an API. And it'll give you a little zip file that either has iOS Objective-C code, Java for Android, or a JavaScript code. And it will basically be a client that you can use to talk to Lambda. So what you do to make this easy on yourself is you use my YAML file, or you read the Ring AWS Lambda adapter, which we'll go into more what that is later. But it is the tool that you have that has a great README. And you go through the README step by step. And if you can't find the word on the page, Control F and search for it. And you'll be like, I don't know why it's over there, but there's that word. Like I told you, very confusing GUI. And just go step by step through that, and you will come out the other side, and it will work. I would like to say, I don't make this sound like a pleasant process, and I won't say it is the most fun I've ever had, but once it is working, it works fine. You don't have to constantly go into something that's breaking and breaking and breaking. So I'll let you know that right now. Okay, so we're going to define something called Arctic Fun Times API in the API gateway. Now, let's get to the part of the presentation that's actually on the title, Lambda. You can pick any of these three platforms. We know the first one is rather huge. It's a microservice, like I mentioned. Amazon has written up a bunch of articles in every flavor of every language. They chose a Gen class-based example where you're instrumenting Clojure to make some static handler methods, and you're doing it in a really way that people don't love doing. And they also give a thing where you write a Java class and you use that in your Clojure. I would push you away from this, one, because many Clojure programmers aren't Java programmers, so the POJO, the Plano Java object example, doesn't make any sense. And the Gen class one uses a bunch of things in the namespace declaration that people may be unfamiliar with and requires a lot of bookkeeping in your classes. There's another thing called Lambada, like the dance, that allows you to make a function that is doing all the static declaration for you. This is fine. It works. But due to some ways that the JVM works and how instance caching works in Amazon AWS, you probably don't want to break up your system into separate endpoints. You want one function to do a lot of pieces because it's cheaper to keep it hot in the cache. So this may not work for you, but if you only have one function, Lambda may be fine, but it will be harder to run locally. The real sauce, the less hard way, is this one. Ring AWS Lambda adapter. This makes it so you can use the standard Clojure web interface, Ring, which if you're not familiar is like the WSGI in Python, and it will use all the same param wrappers and everything like that you're used to. It will use Composure, and this also has all the, here's how you set up all the pain in the ass stuff in this README. This is a godsend. I should send JPB a case of beer or something. I mean, it's really nice. You can run it on your computer, and it will run. It will look exactly like a normal Ring app. The main function is used only for running it locally because the Lambda function is defined separately. And I guess, but I haven't tried this, if you decided to abandon the Lambda direction entirely, you could probably just go get an EC2 instance and run it like a normal Clojure app, and it would work just fine. I don't know that would. You know, there might be some performance issue, but I don't think so. I mean, I don't see anywhere it's in the line that it would be a way. Yeah, I mean, it would be a problem. Okay. So this is an annoying thing that I don't really feel like we should have to think about. There should be a checkbox where we should be able to say, here is money, get rid of this problem. And Amazon hasn't installed that checkbox yet. Or rather it has, but it's like 7 checkboxes, and I'll show you what to do. If you don't have your Lambda handler called, it goes away. That's fine for something that starts up pretty quick like Python or Node. The JVM starts up slowly, especially in the server direction, and that's what's installed on these AMIs that Amazon is using. Clojure starts up even slower. So we sometimes go past the deadline that the API gateway has. It has a hard 10-second non-adjustable deadline. If the API gateway calls out to a Lambda function, and that Lambda function is not done in 10 seconds, you get a timeout error. If you're running a Lambda function anywhere else, you got up to 5 minutes, which is, that's fine to start the JVM. So we have to do some stuff to, one, get it in the cache, and to keep it in the cache. Okay, to keep it in the cache, I'm going to tell you that part first. This right here is in the Lambda function of the console on Amazon. You basically set a CloudWatch event to run every minute and call your microservice. And every minute it'll call it. It airs out. It doesn't matter just as long as it gets into your code, then the thing will stay in the cache. They talk about these limits in the Amazon questions. They have a questions interface, but they're not very well optimized for Google, so you might have to go down to the second or third page sometimes to see the Amazon questions, but once you get in the Amazon questions, you can search through their search functions pretty easily and find problems people are having in the solutions they're getting. But this right here is the solution. It's not going to cost you money because you get a bunch of free calls a month, but this eats a third of those free calls, and I don't really think that's awesome. The other part of the fix is you need to run your function once. Remember I said it's only from the API gateway do you have a 10-second limit. So to invoke the function, you can run a script on your command line. You can use the AWS toolkit, which is a little Python tool that runs in the command line. Or you can do any of the libraries that allow you to run the Lambda functions directly like you might use in the application. Run your Lambda function. Don't really care about it returns. I guess you could make it do something useful if you wanted to. And that might take up to like 18 seconds in my experience to run. But once it's run once, your rest of their calls will be relatively quick. You might get one that's like a second long, but after that they'll be like microseconds. It is really crazy the order of magnitude difference between these different things. Like I said, this slide right here might entirely put you off Lambda, and I would say once this is solved, Lambda is a far easier sell to a business. Okay. The tools in our little example app, and I really am trying to keep our example app simple but not too simple that it's useless. We have a Lambda function called backend production. We're going to stick all our code in that backend production, and we're going to use Clojure to do the 2 endpoints in there. Next, this is not a part of Lambda. You can use a relational database, or you can use no storage at all with Lambda, but we're going to talk about this one because it's what you will often use. So Lambda has the ability to scale up really massively. Most normal applications can't scale up that fast, so your DBs are not configured for what looks like basically a denial of service attack in a traditional thing, in a traditional like thinking paradigm. So what we need to instead do is consider either how to tune the relational database to survive lots and lots and lots of connection, or to shard it or whatever, or we can use a NoSQL database designed for a bajillion things connecting. Dynamo databases, this isn't the only type of Dynamo databases, and what that term really means is there are multiple instances of the database, and they eventually can become consistent. You don't have to use it, like I said, but it will work for many small projects that don't have a lot of relational queries they have to do. If you're really looking at a big, wide document that has 37 fields, and just as long as you get those 37 fields back, DynamoDB is good for you, then you can be pretty fine with it. But if you all of a sudden need to see the coordination date that's before this period and that other thing, DynamoDB might not be for you. And you might have to just confront your relational DB problems that are caused by scale issues. Okay, how do we do this? Oh wow, you see a little Vim problem up there at the top. So we make tables, and we give Amazon an initial budget for how fast we want to read these tables. We pay for those, and you don't pay a lot. You pay dollars a month. But that's one of the few places in this entire system you can't just let it scale for you. And I think we will get something eventually that allows that to auto-scale a little bit better. So you pick how many reads you want to, concurrent reads you want to pay for, and how many concurrent writes you want to pay for. Then you pick which keys. The primary keys are what you can search for, and they should be a good thing to use for sharding. It's a really weird constraint that is very different than normal databases. Strings are often great for this, but here's a big but. You can never change the item that you use as the key, so you will have to replace something in your object hierarchy or in your data hierarchy. So don't use something like an address, because that may change for a given thing. Additionally, you can call these other things, which are I think called search keys. That's not what they're called in the Clojure, but I think that's the Amazon's term. And you can say, hey, we might want to query on this or some combination of these search keys and the primary keys. So that's weird. This is different, but yeah, you just go make a table like this. I will show you what that looks like in just a second. But here's one of the parts that will trip some people up who don't use advanced features of APIs very often. You never, ever, 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 ever want to check in an API key into your source control. That means the lowest level intern that you've ever put at your company could delete all of your customer data. Not really, but that might happen. And it's the type of information that allows that to happen is very hard to keep track of. Very few security apparatus are good enough to ensure that that's impossible. So what you instead do is you put these API keys in environment variables. The env library in Clojure can read it out of environment variables. It can read API keys out of profiles.clj, or it can read it out of things that you set in the program. So you can talk to a key store somewhere. So you should be using env to store your access key and your secret key. I think in the examples, I'm storing them in environment variables is what I'm doing. So that will be something. And you get these from the IAM step we skipped, but the either the AWS tool or the IAM tutorial will show you how to get these keys. And then you put them in your environment, and they will work in the code you have. The endpoint is basically saying US East 1 or US West 2. That is basically identifying the data service, the data center that your database is in. By the way, there is a local version of Amazon DynamoDB. It's okay. Never put real data in it, or real data that you care to lose. If you give nonsense keys and you have a version of that running, it will connect to that, which seems a little buggy to me if you didn't know that that was going to happen. But it has to be running for that to happen. Okay, here's how you specify a table. In the code, I show you how to specify a normal table, one that only has a normal primary key. But this is the table we're using tonight because I wanted to make a table we could search for things by event and or name. So the primary key is going to be the event. I'm going to say that's the thing that's the best thing to shard based off of and to segment your database if it got really huge. And then I'm also making it so we can search on the person's name. You see that in the range key def. Hopefully the comments in the code are useful to you. If you don't find them useful or you don't find them understandable, please message me or put a comment in GitHub and I will try to correct them. Blocking, it's a long discussion, but just leave it as true in your first thing. And then here's the throughput is where we're specifying how expensive we want our monthly spend to be and how many people can read concurrently and how people write concurrently from this particular database table. Okay, this is Michael Langford specific code. So Faraday, which I've imported as far, is the library to talk to DynamoDB. You can use it on a local client to talk to a DynamoDB service without involving Lambda at all, or when you put it on Lambda, it will talk to it just great. So right here, I'm basically iterating through a list of tables, or actually a dictionary of tables, and making sure everyone exists. This will create the table if it's not there, and if it is there, it's a no-op, basically. I will warn you, this is another thing where you're going to have to possibly add more credentials than you'd ever want to have on a normal user, because creating DynamoDB tables is yet another permission that might not be in your normal roles. So there we go. And this is just parsing that data structure from before. That's all it's doing. Okay, we have the entire architecture of our system. Hopefully, I did not have it going out one of your ears while I was pushing it in the other because I presented too much at once. I didn't present a lot of things out of that exact worry. There's a lot of different things because, like everything Amazon does, it's designed to run giant industries off of. So they have tons of sharp edges and tons of sophisticated tools. So here's a bunch of stuff that you will probably end up looking at further if you do this in a big product. So here's the URL for the example project I made for you all. And let me get this up right here and show you what it looks like when it's running. Okay, so here's the directory for that example project. I have added 2 folders beyond what's the normal Clojure stuff. Client scripts is our entire client. So we introduced that first in our talk, so I'm going to go in there. So I have 2 scripts here, or 2 pairs of scripts here, which are the entirety of the client software. This is taking the place of an iPhone app or a single page app, single page web app. So let's just look at what one of these looks like. So this would, right here, this would get the root directory of our AWS endpoint, and whatever function has been tied to Lambda there, it would return the information. So to show you that it is indeed local, we can run it because the application is not running here right now. You see connection refused. So let me come over here and do that. I'm going to run the app, and this is using that AWS ring adapter. So you can just do a line run and it works. So our glorious Java startup time. Okay, so now we do list names. So you see a bunch of names here. The way I have currently architected this app, it always talks to the production AWS DynamoDB service. This highlights one of the weaknesses, is they don't have a bunch of best practices that says this is how you make it go to production versus staging, and this is how you do it locally. You can do that stuff. It's not a lot different than when you're doing it with the database. You just have to go do it yourself. There's not like a guy, handy dandy guy that does it easy. So right here, I ran curl, and this is JSON that you're seeing returned, and sorry I didn't pretty print it, but you're right, you see the entities coming back. So there's a guy named Jeremy going clubbing, a guy named Michael going clubbing, a guy named Eric going to an event called Dance, a woman named Jenny going to an event called Dance, a woman named Vesper going to an event called Dance. That is reading from the real database. If I pulled up the console, you would see that. So let's go ahead and add one. So this is adding it, and my add method is also quickly echoing back a read of the table. DynamoDB is an eventual consistency database. You can say, do a real read that is consistent right now, but Amazon charges you more money for it. It's more time or something like that. But most of the time, the stale read will be consistent enough. So right here, you can see that quote-unquote stale read was right there, and you see we added Justin to it. You can see on the right-hand side, I have some printfs in the code. I wish I could format that better, but I didn't think to pretty print that for the presentation. And you see it basically doing the local stuff. And we can deploy this code to Lambda. We go by using one of the wonderful things. Oops. So again, I hopefully have documented this well enough for you all to be able to do this if you want to. There's a line again plugin. This one right here will allow us to push that YAML file I mentioned up and reconfigure the API gateway. And this next one around here allows us to push the code up to S3 and then tell Lambda it's on S3. I think you can directly upload it too, but I didn't. So I'm going to use this plugin right here next. Whoops. Okay. So there's two functions for it. There's install, which you do the first time you put the function in, and then there's update. And they're just mirroring the Amazon app. This isn't the library writer just failing it at item potency. That is a hard one. Production. There we go. So this is compiling our application, making an uberjar, and then copying that uberjar up to S3, which is the Amazon's hard disk in the cloud system. And then it's talking to the console for AWS Lambda and saying, this function has been replaced, and then it is replacing that. It is not invoking the function for us. And I told you, you need to keep your instance in the hot zone, keep it going. I've already set up that thing that is already pinging, so we don't need to do that in this example. But I made a script for you all to see what it looks like to evoke it. So we're going to go to scripts. These are the server-side scripts, basically. Warm up production, and you can see right here it's using the command line utility for AWS, and it basically is just throwing a stupid payload at the system, and then it puts a log on the desktop. The fact that it runs is all you need. Is just as long as it's connected up to the right resource, it'll get you into the hot zone there. So and this can take a little bit of time. So we were already hot. If this wasn't hot, that can take like 18 seconds. So yeah, that's the less than glorious part of all this. Okay. This is what it looks. This is the other line plugin I mentioned. There's two things it does. Update is taking your YAML file and replacing what you see in the GUI up there and the specification for your API. And it also is copying all that, like that copy-paste JavaScript I was mentioning. Deploy is the thing that takes it from the area where you're specifying it and puts it on the real internet. That's where you get a real URL that you can talk to. And you will get the same URL every time for every one of your deployments. So you can call one deployment production, you can call one staging, and you have two different routes, some going to different Lambda functions and stuff. That's part of the way you handle the staging production bifurcation that you want generally when you're doing an app professionally. Okay, to wrap it up, let's quickly go into the source because, like I said, I tried to keep this pretty brief for y'all. Okay, there's not a lot to talk about in core, so let's go to handler. Okay, if you don't do Ring very much, middleware in Ring just is adding additional dictionary lookup fields based on things in the environment from the HTTP request. It makes Ring very nice, but it's not a lot different than things that happen in other languages. Composure is the routing language. It's how you say, when someone makes a GET request here, you go there. They make the macros GET and POST. You will see lower down on the screen right here. And I don't actually use the JSON handler, and then we're also importing RDB. Okay, look at the def route section right here. When you get at the root of our route, I'm going to call that function right there, which is going to call our database. And when you post something, I'm going to expect it to have a name and an event, and I'm going to pull that out of the parameters, and then I'm going to pass that to a handler function, which is going to pass it to the database. You would want to do validation often in these handler functions, and then only if it's valid, point it to the database, but I left that out for simplicity's sake and time. So the functions it's calling is up here. This R response is something that wraps things up to make it so it comes back with HTTP codes and things like that. So down here, this def app thing is what we are calling from the core function, and this is what we run when we run it locally. This def handler thing is what we are calling when we run it on Lambda. You can change the middleware you have in these two situations if you want, and pay close attention to the fact that there are dashes here, and where there are dashes and where there are underscore in this example is important because sometimes they're looking for dashes and sometimes they're looking for underscore. Alternatively, you can just pick a single word module name and not have that headache. But it's not that hard. So that's all you have to do for a handler. And then, don't know what's going on there. Oops. Okay, so you've seen most of this file. Faraday, that's the module if you wanted to see it. And we just ensure the tables exist there, and then we fetch and post to the database. And then lastly, I want you to see that core is nothing. I don't even have like the auto reload stuff that everyone wants to put in their examples these days because I didn't want anyone to get confused about what's going on with this example. So I'm using HTTP kit just because it's easy to use, not because of a performance reason. I pass a port, I pass the handler from handler in a run. And I call DB setup here, but I also call DB setup in absolutely every function in the DB module, so it's actually superfluous. So that is the entirety of the app, how it runs, and let me know if there's anything you have questions on.